Okay, there we go. If we look at the back of 58, start with number 6 right here. Again, all I got to do is count my up and my down, my left and my right, square them, add them, take the square root. The more we do this, the easier it's going to become. So what I'm going to do first is I'm just going to draw my lines. I'm not even going to worry about counting. I'm just going to draw my lines first because it's easier for me to count when I have those physical lines visible. All right? My red line here is 1, 2, 3, 4, 5, 6 squares long. And my blue line here is 1, 2, 3, 4, 5, 6 squares long as well. So the two numbers that I'm going to use in this process are 6 and 6. I'm going to square them. I'm going to add those two numbers. Then I'm going to take the square root of whatever we get. So when I square them, what do I get? 36 and 36. I'm going to square them, add them, take the square root. What happens when I add them? I get 72. What am I going to do with that 72 now?
Oh, you can square root.
I'm going to take the square root. Square them, add them, take the square root. I'm going to say it over and over again until it gets stuck in your head. Square them, add them, take the square root. Is 72 a perfect square though?
Yeah.
Ooh. No, it is not. It's close to 74, in between 64 and 81. It's going to be somewhere in between 8 and 9. But let's break this up and do a factor tree. What two numbers multiply to give me 72? 8 and 9. How can I break up 8? 4 and 2. What about 9? 3 and 3. Anything else I can break up here? I can break up the 4 into 2 times 2. 2, 2, 2, 3, 3. Right? This is a good review of our irrational numbers. I'm going to take all 5 of those terms, put them under my square root. 2 times 2 times 2 times 3 times 3. Is there any pairs here I can circle up? Pair of 2s and a pair of 3s. So let's take a look, right? The pair of 2s comes out in front. The pair of 3s comes out in front. What's left in the square root? A single 2. And what do we do with that 2 and that 3 out in the front? We multiply them, giving us what? 6 root 2 units. That is the length of our distance between these 2 points. 6 root 2 units. Comes out to 8 point something. Anybody get 6 root 2 on number 6? 3 people, 4 people, 5 people, 6, 7, 8, 9, 10 people? Okay. Good. So we can't forget about how to break this up. This is an integral, meaning a very important part of this unit, is taking an irrational number or an imperfect square, making a factor tree, setting it up, bringing out your pairs, multiplying them, leaving your remainder. We got to remember how to do this, especially with what we're going to talk about today and tomorrow. Let's go up to 8s. Number 8s. Ooh, those are pretty far apart. I'm going to start out by drawing my lines. There's my first line. There's my second line. This red line here has a length of, what is that, 12? Yeah? That looks like 12 to me. And this blue line has a length of what? 15. Great job. 15. So a lot of our problems might start from just a simple miscounting. If we miscount how many boxes, we're using the wrong numbers in this process, right? I'm going to use 12 and 15. I'm going to square them, add them, and then take the square root. What does 12 squared give me? 144. What does 15 squared give me? 225. I squared them. I'm going to add them. I get 369. I squared them. I added them. Now what do I do? Take the square root. 369 is not a perfect square. 169 would be a perfect square, but 369 is not. So when we have a weird number like this, I told you guys to just kind of divide it by 2 or split it in half. But this is an odd number, so we can't divide it by 2. Let's try dividing it by 3. What would happen if I divided 369 by 3? Let's see. 369 divided by 3. Perfect. 1, 2, 3. I'm going to make this smaller. I get 123. Now 123 is another odd number. I can't divide it by 2. But let's see if I can divide it by 3. Look at that. I get 41. Can I split 41 up at all? Well, let's see. If I divide that one by 3, oh, that's not very nice looking. I don't want to do that. So we're going to leave 41 as it is, but I do have a nice little pair of 3s. Just like before, I'm going to write my 3 prime factors underneath my square root. I'm going to look for any identical pairs. Do I have one here? I sure do. My pair of 3s comes out in front. What gets left behind? 41. So my answer, 3 root 41 units. 3 root 41 units. It's a weird looking answer, but that's what we get. Yep. That's fine. Just take the blue pass. Let me send it. And last but not least, number 9. This one's not too bad. I'm going to count over. I'm going to count down. We went over 1, 2, 3, 4, 5, 6, 7 spaces. I went down 1, 2, 3, 4, 5, 6. So my 2 numbers I'm going to use are 7 and 6. I'm going to square them. 49 and 36. I'm going to add them. What do I get when I add them? Yeah. If I flip them?
No, like, because I had 36.
Oh, so you're saying if you put the 6 first and then the 7? Great question. It does not matter what order, because 49 plus 36 adds to 85. Close. A little flipped around. If I did 36 plus 49, what would I get? If these were the other way around, if I did 36 plus 49, what's that equal to? Same thing, right? Order doesn't matter. We're squaring the numbers and we're adding them together. So unlike the distance formula, where our order that we plug numbers in was very specific, this one it doesn't matter, which makes it a lot easier. Just like I said before too, it doesn't matter if I start here, I go down 1, 2, 3, 4, 5, 6 spaces, and I count over 1, 2, 3, 4, 5, 6, 7, I still have the same 2 numbers, 6 and 7, right? Because what we're finding is the distance of that diagonal line. So I got 85, I squared them, I added them, I took the square root. Well, sorry, now I'm going to take the square root. 85, right away I see that number ends in a 5, so I'm going to divide it by 5. Why is this calculator always so big? If I do 85 divided by 5, I get 17. Can I split 17 up at all?
No.
No. Is there any pairs in here I can take out? No, it's just a 5 and a 17. I cannot do anything with this. What is my answer going to be? 85 is incorrect. 85 under a square root. Square root of 85 units. You may be thinking, oh, well, I got 85, it's the same thing. It is not the same thing. The square root of 85 is about 9 units. Right? If this side is 6, this side is 7, and this side is 9, that makes sense. If this side is 6, this side is 7, this side is 85, that would not make sense. And we'll talk about why that is here with our triangle overview if we have time. I appreciate your optimism. All right. Those are 3 really good ones to go over. We had one that was easy to break down, like 72. One that was a little bit harder to break down, like 369. And one that we couldn't break down at all. We asked number 3 too, just very quickly, because this one's a nice perfect square, just to round us out. I'm going to count up. I'm going to count over. Got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to square them. I'm going to add them. I'm going to take the square root. What's the square root of 100?
10.
10 units.
Right, so I wonder.
No, the square root of 100 is just 10.
Yeah.
If it's a perfect square, you do not want a square root in your answer. If it's an imperfect square like 85 and we can't break it down, you do want a square root in your answer. Right? These are the lessons we started this unit out with. Right? Square root of 100 comes out nice and even, just 10 units. And that makes sense. If this side is 6, this side is 8, this side is 10, that would make a triangle. The square root of 10 is like 3 point something. That wouldn't make sense for this triangle. All right?